Welcome. We are the Ministry of the Real Truth, and today we are going to delve into a book we found in public access, public domain, by Alfred Wegener, The Origin of Continents and Oceans, 4th edition, published by the House of Commons Library. First, we are going to have a look at the history of Alfred Wegener. Who was he? He was a German, born in 1880, died in November 1930, a climatologist, geologist, geophysicist, meteorologist and polar researcher, so he had quite a lot of expertise behind him. During his lifetime he was primarily known for his achievements in meteorology and as a pioneer of polar research, but today he is mostly remembered as the originator of continental drift hypothesis by suggesting in 1912 that the continents are slowly drifting around the Earth in the German continental Skirbung. His hypothesis was controversial and widely rejected by mainstream geology until the 1950s, when numerous discoveries such as paleomagnetism provided strong support for continental drift and thereby a substantial basis for today's model of plate tectonics, which is the scientific theory that the Earth's lithosphere comprises a number of large tectonic plates which have been slowly moving since about 3.4 billion years ago. The model builds on the concept of continental drift, an idea developed during the first decade. Wegener was involved in several expeditions to Greenland to study polar air circulation before the existence of the jet stream was accepted. Expedition participants made many meteorological observations and were first to overwinter on the inland Greenland ice sheet and the first to bore ice cores on a moving Arctic glacier. Biography, early life and education, and here's a plaque commemorating him at his former school. Well, they'll be very proud of him. Oh, look at our student. He became this. And there's more information here. And he had a family. Then World War I came along and he was called up for First World War in 1914. On the war front in Belgium he experienced fierce fighting, but his term lasted only a few months after being wounded twice. He was declared unfit for active service and assigned to the Army Weather Service. So he probably fought in trenches alongside Adolf. May not have met him though, who knows. Nevertheless, he was able in 1915 to complete the first version of his major work, Die Entstehung der Kontinente und Ozeane. German ain't that great. We haven't really delved in it for years. The origin of continent and oceans. His brother Kurt remarked that Alfred Wegener's motivation was to re-establish the connection between geophysics on the one hand and geography and geology on the other, which had become completely ruptured because of the specialised development of these branches of science. Interest in the small publication was, however, low, also because of wartime chaos. By the end of the war, Wegener had published almost 20 additional meteorological and geophysical papers in which he repeatedly embarked for new scientific frontiers. In 1917, he undertook a scientific investigation of the tracer meteorite, known as the Romershausen meteorite, an astronomical relic found in a wooded area near the Romershausen district of Schwarzwaldstadt in northern Hesse, Germany. Maybe that put Germany on the map then. Post-war period, 3rd and 4th Greenland expeditions. This is all the things he was up to. Continental drift theory. Wegener first thought of this idea by noticing that the different large land masses of the Earth almost fit together like a jigsaw puzzle. The continental shelf of the Americas fits closely to Africa and Europe. Antarctica, Australia, India and Madagascar fit next to the tip of southern Africa, but Wegener only published his idea after reading a paper in 1911 which criticised the prevalent hypothesis that a bridge of land once connected Europe and America. It's probably a solid... this is the one where it was blocked by ice, no one can get across until the ice age and it melted, and then there's this bridge from one continent to the other, of which the Asians came across and became the Eskimos, etc., etc. So we're going to have a look at this video we found on YouTube. What did this look like? Or what did Pangaea look like?
In the early 20th century, the German scientist Alfred Wegener noticed that the eastern coast of South America and the western coast of Africa fit together. In the early 20th century, the German scientist Alfred Wegener noticed that the eastern coast of South America and the western coast of Africa fit together nicely, almost like two pieces of a puzzle fitting together. Then Madagascar fit nicely around the side of Africa, while parts of India seemed to have a place as well. Despite heavy criticism, Wegener went on to publish the book The Origin of the Continents and Oceans in 1915, pushing the concept of what he called Urkontinent, meaning supercontinent in German, except in a 1920 edition of the book where, for a single time, he called the land the Pangaea of the Carboniferous, coining the term from the Greek pan, meaning the entire or all, and Gaia, meaning earth. Of course, it was the Latinization of this word that became the more common phrase now, Pangaea. And today, Pangaea and the larger theory of plate tectonics are more or less common knowledge. Beyond that, though, I don't know if I've ever actually seen a good prediction on what the continent actually looked like. Most maps you'll find are either too simplistic for my taste, or just an artistic representation of Pangaea, which can trade accuracy for aesthetic. So what I'd like to do today is make a rough estimate of what some of the geography of Pangaea was like, and hopefully by the end we'll have a cool map or something. Obviously this will just be an approximation based on what we know so far about the supercontinent. So with that in mind, let's get started. First, Pangaea itself existed for around 160 million years, forming around 335 million years ago, and breaking apart roughly 175 million years ago. Over this time, Earth's geological engine was still turning underneath.
So if it broke and drifted apart 175 million years ago, then the biblical account would be an error, wouldn't it? If the scriptures say that God, the earth was just a watery mass, there's nothing on it, no life, no land, nothing, no earth. And then suddenly he commands, let there be land, and it pops up out of the sea according to the Egyptian myth as well. It just comes out of the sea, out of the watery depth, and it's this one big landmass, and everybody's on it. Adam, Eve, Cain, Abel, probably the pre-Adamic Cro-Magnon cave dweller, hunter, gatherer, right? According to the original ancient, very old Tab Asherit manuscripts in the Lishana Articus Hebrea, the language that God spoke to Adam and Eve in the Garden of Eden, and the men at the Tower of Babel spoke. So if all these descendants of Adam and Eve eventually they supposedly interbred with the cave Cro-Magnon hunter-gatherer and had these hybrids, and if they had descendants or sons and daughters who had descendants who had descendants who had descendants in the specific Near East area, because the Bible story of Garden of Eden, etc., is all centered around the Near East. Mesopotamia, all those surrounding areas around it. It's not talking about Africa yet, or anyone went to Africa yet. It's basically that Near East, Iraq or Iraq, Iran, Syria, etc. All these people were in this one geographical location for so long, and then at some point these tectonic plates shifted and then separated. Okay, so you can't really say that 75 million years ago that's when they split. Well, you could, but then it would totally make the biblical scriptures look like fiction, to put it nicely. Okay, so we'll continue with this for a little bit longer.
meaning that on a geologic timescale, Pangaea would have been constantly changing, and so one general map of Pangaea can't really be made. Instead, we're going to need to pick a specific time in Pangaea's past to look at. This one's going to be a bit arbitrary, but we're going to aim for between 190 million years to 230 million years ago. This was around the...
Just remember, these are estimates, okay, and these are the supposed dinosaurs, etc., that were running around on the planet at that time. There was nobody there, so how do we know? This is an artist's impression. This is a scientific theory. They study, they research, etc., to try and bring it as fact, right? Established fact. Yeah. There was no person there, supposedly. If there was 76 million years ago, is there any pictures or depictions of the proof, etc., that they were there too?
Time of the Triassic-Jurassic extinction event, during which 20 to 30% of all marine species went extinct. For this time, the most accurate map for Pangaea I could find was this one. But using this, we can now begin to look at specific features, and to start, I'd like to look at some of the mountain ranges that would and would not have existed during this time. For starters, nearly every major mountain range on Earth today had not formed yet. The Himalayas, for example, only began to form 50 million years ago when India...
So another estimate, assumption. The 50 million years ago, whatever, is just a guess. Okay? They can't point exactly, okay? But it's pretty near exact if there's evidence here for that.
Collided with Asia, and overall it was the tearing apart of Pangaea that actually gave us many of our mountains, and the reason these all happen to be our tallest is because they haven't had enough time to erode. So to find out what would have been around during this time, we need to look at some of the oldest mountains remaining on the Earth, such as the Appalachian Mountains of the United States, the Little Atlas Mountains of Morocco, and the Scottish Highlands of Great Britain, all of which are nearly 500 million years old. Now, it just so happens that these three mountain ranges would have formed a single continuous mountain range across the supercontinent called the Central Pangaean Range. And while none of these ranges stand particularly high today, 4 different mountain building events in the past produced a mountain range that was once as tall as the Himalayas are now, essentially separating the continent between the two remnants of older supercontinents, Gondwana and Laurasia. It was only with several hundred million years of weathering and erosion that... I'm going
to have a look at that again.
Essentially separating...
So this could have been what it looked like. It could have been what the Earth looked like before tectonic plate shifts.